Okay, the next question we're going to do is number 52. This is a Hess's Law question. These are really good questions. There is a simple strategy that will enable you to nail this one. You just got to make sure that you, if nothing else, you're going to work out some of it on scratch paper, but you want to include all of the necessary data to support your conclusion. If the setup is sound and your final result's off, it's not going to be significant because I'm going to be testing the setup. It's your logic and your support that's being tested here. Okay? And we're taking advantage of what is delta H naught? Anybody care to tell me what that's called? Delta H. Yes, the change in enthalpy. And recall that enthalpy is what type of a function?
State function.
It's a state function. And therefore it has two properties that enable us to solve this problem. Yes?
The difference between like a state function and a path function was that example of like going up the stairs that you said, right?
Yeah. A state function is path independent.
Path independent.
And not a state function depends upon which path you take. So an example would be heat is not a state function. It depends on the path. And work is not a state function. It depends upon the path. Okay. But the sum of heat and work turns out to be the energy. That turns out to be a state function. And it is independent of the path. An example of a state function would be the potential energy that we used in that example where my potential energy depends upon my height above the Earth, not which path took me from point A to point B. The change in my potential energy depends on my initial and my final height only. The same thing applies with the state function. So it is path independent and it's additive. What does additive mean?
It means it's not like a vector where it doesn't depend on the direction and always be additive.
No, well, no, that was a good try, but actually what it means is if I double the amount, I double the amount. In other words, if I double the amount of material, if it's this much for 1 mole, then it's going to be, if I double the amount of moles present, of reactants present, I'm going to double the enthalpy for the reaction. If I cut the amount in half, then it's going to have half as much enthalpy corresponding to that reaction. So that's what the additive property comes from. Those two characteristics, which are the defining characteristics of state functions, which we're exploiting here to solve this problem. Because essentially, I don't know the enthalpy for this particular reaction. So what I would do to start out is I would call this reaction number 4 so that I can start to test this out. And the key to solving this is I'm going to look for where I need all of these reactants to occur, but I need methane. So I look for methane, and well, let's look at the carbon tetrachloride first so I can see what's in reaction 1. Here I've got 1 carbon tetrachloride. You see it? 1 carbon tetrachloride, and it's on the product side. So that means, tentatively, I would say that 4 is going to be equal to 1 times reaction 1. Because reaction 1 has 1 carbon tetrachloride produced. Now I'm going to look for, in reaction 2, I've got methane. But in reaction 2, I've got 1 methane, but it's a product. In the actual reaction 4, I have 1 mole of methane, but it's a reactant. So what do I have to do? I reverse the reaction. So it's going to be minus 2. I didn't have to multiply it times anything because this is 1 mole of methane, 1 mole of methane. And then now in the last reaction, I have hydrochloric acid as a product. What have I got in reaction 4? I have 4 moles of hydrochloric acid, or hydrogen chloride. So what do I have to do to this reaction? Multiplied times 4. So it's going to be plus 4 times 4. Why plus? Because this is a product. And this is on the product side.
4 times 3.
3.
Oh, yeah. Sorry. Thank you very much. Thank you. So, if this is indeed true, then it's going to turn out that delta H naught 4 is going to be equal to delta H naught 1 minus delta H naught 2 plus 4 times delta H naught 3. But I have to confirm that this is true before I go ahead and do the math. And so this information should be on your test. Somewhere you want to have this, which is your tentative assignment. And then you're going to want to, underneath there's a room provided, I'm going to need to write these reactions in this sequence. So I'll rewrite 1 under here, C, and that's GR stands for graphite, plus 2 chlorides gives me carbon tetrachloride. And then it's minus number 2, so I have to reverse it. CH4, which is methane, going to C graphite plus 2 hydrogens. And now, so this is 1, this is minus 2, and now this last one's going to be 4 times 3. And 4 times 3, what's 4 times 1/2 hydrogen? 2H2 plus 2 Cl2s, 2 chlorines, is going to give me 4 HCl. And I have to see if they indeed do add up to the desired reaction. What cancels? Anything that occurs on both sides. So, I've got carbon graphite on this side. I've got carbon graphite on that side. I have 2 chlorines, but I don't have 2 chlorines on that side. Okay, I've got a methane on this side. I don't have a methane on that side. I have 2 hydrogens on this side. I have 2 hydrogens on that side. So I've got 2 more chlorines. Okay, on the right-hand side, I've got carbon tetrachloride and 4 HCl. So I'm left with methane plus 4 chlorines gives me carbon tetrachloride plus 4 HCl, which is confirmation that this indeed, that particular, our proposed sum is the proper one. Can you see this? See what I did over here? Okay, this just confirms it. Now I'm going to actually have to do this math. So on my scratch paper, the parts I'm going to have to work out in advance, I'm going to have to take delta H3 and multiply it times 4. So minus 92.3 times 4. On scratch paper, that's a 12. 2 times 4 is 8, 9. 9 times 4 is 36. Okay, 369.2. So this means that delta H equals 1, which is minus 139 kilojoules per mole, minus 2, which is, what is minus a minus? So I'll just put it out. Minus 74.9 kilojoules per mole, plus, and now delta H3 is negative, so, and I'm viewing it in the same order, so it's going to be minus 369.2 kilojoules per mole. And now have to do this, basically I'm going to add these all together, so it's going to be 74.9, I'll do this on scratch paper, 139 kilojoules kilojoule, 0.0, 9 and 2 is 11, 99 is 18, 19 and 4 is 23, 8 and 7 is 15, that's 18, 3 and 2 is 5. Oh no, this is plus, isn't it?
Yeah, you can't do that.
I just screwed up. See what I just did? I messed up completely. Now I got to start over. This one is negative. This is plus 74. So I'll just take the 74 from that. Okay, and then I'll add the result to this. So 12 subtract 9 is 3. 8 subtract 4 is 4. 6 subtract 7 is 9. And that would be 293. So it's that. So it's minus 294.3. This is on scratch paper, so it doesn't matter. And plus 139 kilojoules. 0.3, 9 and 4 is 13. 9 and 13, 2 and 2 is 433. Equals minus 433.3 kilojoules per mole. Did I screw up anywhere? What? Okay. So now I can erase my scratch paper. This is scratch paper. This is what I want to see on the test. So practice doing that, including all the information that supports your answer. The answer itself is almost irrelevant. You saw me make a mathematical error at the end. That mathematical error would have cost me a couple of points. But my setup was okay. And that's what I'm actually looking for, is the setup. Okay? Any questions on this? So this one's pretty straightforward. Okay. Which brings us to question number 51. We're going to have fun with that. Oh, that's a wrap.